All right, so for today's topic, once again, we're only going to be looking at characteristics of quadratics. Characteristics of quadratics. So this is still like a getting to know you, sort of type of video. Your assignment is going to be relatively short. So we're just going to be looking at specific things of quadratics, and mainly we're going to be looking at a graph. I could easily just create right now. And we're going to be talking about different aspects or characteristics of the graph. So I'm just going to do something like this. Okay? Actually, that was kind of bad. Wait, what happened? What? Okay. Oh my god, that's even worse. Whatever. So, and I'm just going to put some points down here. Actually, let me try a better. Whatever. Okay, that's fine. I'm just going to put some points down here. Okay, so the first thing we're going to be looking at in terms of characteristics are the intercepts. Now, if you've forgotten what an intercept is, it's just where it's crossing the x-axis or the y-axis. Okay, so if you notice on the y-axis, I'm going to use the color yellow. It is crossing right there. Okay, so we have a y-intercept. Every quadratic will have a y-intercept. There will always be a y-intercept, okay? But you also have x-intercepts. And this is where they cross on the x-axis. I'm going to use the color green. Okay? X-intercepts are probably one of the most important things about quadratics, okay? And we use a lot of different names for x-intercepts. Most people don't even say x-intercepts. And I'm going to tell you what are some of the different words that people use. So if you ever watch other YouTube videos or next year, you already know what they're talking about. Another word for x-intercepts are roots. So if we talk about the roots of a quadratic, they're talking about these green points over here, okay? They're talking about where it's crossing on the x-axis. Another word used for x-intercepts are zeros. The reason being is at these x values, y is equal to 0 here. And one thing you'll learn is, obviously we've been solving linear equations and we've been solving for x. Quadratics, a big thing is solving for what specific values of x make that quadratic equation equal to 0. Hence, these x values are called zeros also. I know it's kind of weird. Another important point, and you know what? Actually, let me color code this. Right? Let me do this. The y-intercept is on the graph there. The x-intercepts are there. Whoop. I'm going to use blue for the vertex. This is called the vertex. Some people also call it the apex. Now, the vertex, if you think about it, it's either the lowest point on the graph, right? Either the lowest or the highest. In this case, it's the lowest point on the graph. The quadratic cannot go any lower than the vertex. We also have this special thing. I'm not gonna color code it. I guess I could actually. We have this thing, and I'm just gonna try to draw it with the red one. This is called the axis of symmetry. And if you don't like using the word axes, just use line of symmetry. This is essentially where the reflection occurs for the parabola. And the equation looks something like x equals a number. I don't know, right? In this case, it looks like 3 or 4 or whatever. So sometimes I'll talk about the axis of symmetry. That's just asking where's the line of reflection. Or yeah, the line of reflection is another way. Actually, I'll color code this. And there's one last thing, one last characteristic about quadratics in general. And it's whether, does it open up or does it open down? Right? Because quadratics can either look like this or like this. They can go upwards or downwards. Here, you have a lowest point, and here you have a highest point. Now, these are all the different things, right? You can talk about intercepts, you can talk about the vertex, axis of symmetry, is it opening up or down? Just like linear equations, right? You either have, it's either increasing or decreasing. And the other two things you can talk about is what the slope is and what the y-intercept is. For quadratics, there's just so much information about it, okay? There's a lot of different things. So what we're going to do right now is we're going to take a look, right? Remember how there was 3 different forms of equations of quadratics? We have standard, we have vertex, and we also have factored form. And if you forgot what they look like, that's fine. I mean, what they're written like, I'll write them ahead again. Y equals ax squared plus bx plus c. Right? That's a quadratic in standard form. Y equals a times x minus h squared plus k. That's in vertex form. And then something that looks like factored is y equals a times x minus m times x minus n. And we're going to talk about what each of these letters represent. And I'll use a different color actually. So for all of these, and it's going to be kind of hard to write it down. That's fine. Imagine there's like a space right here, right? A tells you if the graph opens up or down. A tells you if the graph opens up or down. So if A is positive, do you think it opens up or down? Yep, if A is positive, it opens up. And if A is negative, it opens downward. Now, that's how you can determine, right, if it opens upwards or if it opens up downward. Now let's look at standard right here, and I'm going to talk about what each of these numbers represent, okay, or what they're utilized for. So A is true for all types of quadratics. They tell you if they open up or down. Now, the C here, what if I were to tell you that's your y-intercept? Also known as your starting value. Whatever the starting value is, if it's like 7, you know that the quadratic is going to cross at y equals 7. Now, the B is kind of weird, okay? It helps you find something, right? The B is weird. So if you wanted to find the vertex of a quadratic that's in standard form, the x value of the vertex, I know it's kind of weird, but watch me. Negative b over 2a. If you wanted to find either the highest or the lowest point, but just the x value, you can take the b value and the A and go ahead and figure out what the heck this is. I know it's kind of weird, but once you start doing it, it gets easier, okay? It's a lot of information right now, but that's okay. Take these notes and seriously, try the problems out, okay? And that's about it for standard, okay? If you look at a standard equation, that's all you can tell. Is it going up or down? Where does it cross on the y-axis? And where's the vertex? That's it. Moving on, if you have a parabola that's in vertex form, obviously you can tell if it's going to open up or down, right? Depending on what the value of A is. And there's one more, sorry. There's only one thing, well, there's two things, right? It tells you whether it's opening up or down, but H, comma K is the vertex. That's why it's called vertex form, because it tells you the vertex. And that's it. A quadratic in vertex form only tells you the vertex. That's it. Now, we have factored. If you have an equation in factored form, there's a couple of things this equation tells you. A will tell you, right, whether it's opening up or down. I'm not going to write that because that's true for all equations. M and N are your x-intercepts, also known as your roots or zeros. It's really important, right? If you have an equation in factored form, it's important because it tells you where it's crossing on the x-axis. And if it's crossing on the x-axis, guess what? You can find where the line of symmetry is. And guess what? If you know where the line of symmetry is, you know what the x-coordinate of your vertex is, right? Let's go back to this picture. If you know what the line of symmetry is, you know what the x-coordinate is of your vertex. So if you wanted to find the x-coordinate of vertex, you actually add M and N and divide by 2. Now, I'll be honest, you don't have to remember all of this, okay? With time, a lot of it will start making sense and you'll start to remember little tricks here and there. I'm introducing everything, but you don't need to remember everything, okay? You remember what you want to, I guess. There's one last thing that a factored form equation tells you, and that's your starting value. Your starting value is, watch, A times M times N. You end up multiplying all three numbers to figure out what your starting value is. And remember, the starting value is just your y-intercept. So all of these different types of they're all quadratics, but whatever form it is, they each tell you different things about the quadratic, okay? The next couple of videos are definitely going to be, they're not going to be as conceptual, right? This is pretty theory-based. The next couple of videos, you're actually going to be doing math, okay?